Welcome to the DX Today podcast, where you get facts, not hype. Okay, let's unpack this. Today, we are diving deep into a stack of strategic analyses and some really eye-opening research that I think fundamentally reframes the challenge of unmanaged technology in the enterprise. For years, we've all worried about shadow IT.
Right.
Employees downloading unapproved software, maybe a slick project management tool or some unsanctioned PDF editor. But the sources you've provided, they make it crystal clear that problem has evolved, or maybe metastasized is the better word.
I think metastasized is exactly the right word.
We're now facing the crisis of shadow AI, an invisible, sprawling network of autonomous decision-making agents operating deep within the corporate perimeter.
And what's so fascinating here is that the risk isn't static anymore. This isn't just about an unmanaged tool, which was, a fixed function piece of software. We are talking about the emergence of an unmanaged workforce. A shadow army, as the sources call it, an army that reasons, executes really complex multi-step processes, and adapts its behavior without any oversight.
No oversight from IT, from security, from compliance, from anyone.
Exactly. So our mission today is to move past the hype and provide a forensic examination of this critical risk. We need to connect the raw technical security implications to the severe new legal liabilities that organizations have to address immediately, particularly now in 2025.
That focus on liability is so key, especially for you, our listener, the learner, who needs that quick but really thorough understanding. This deep dive is built for those aha moments. We'll structure this around three central themes. First, we have to define the threat. How is shadow AI functionally different from the shadow IT we thought we knew?
A whole different ballgame.
Second, the legal and financial impact. We'll get into the autonomous attack landscape and some of these crippling new regulations. And finally, we'll talk about the path to control. A clear governance strategy, not for prohibition, but for safe enablement.
Let's start by grounding this in that core distinction, because if your CISO is still focused on just, blocking employee access to ChatGPT's public chat window,
You're fighting last year's war.
You are already looking at last year's problem. The real threat has moved way beyond that simple Gen AI interface.
So how do we define this new problem in a way that really separates it functionally from the old threat? It's not just a change in technology, right? It's a fundamental change in the behavior of the software itself.
It is, and that distinction is rooted in two concepts: autonomy and probability. Traditional shadow IT involved unmanaged software, sure, but that software required manual human input for every single step.
Right.
If you used unapproved PDF editor, you had to manually open the file, select the text, click save. It was a passive, fixed-function tool.
It was digital disobedience, I guess, but it was still totally reliant on the user's actions.
Exactly. Shadow AI, in contrast, consists of autonomous software agents. They're probabilistic, their output isn't fixed. They reason, they choose, and they decide their next move based on a goal.
A goal, not a specific command.
Precisely. And crucially, they are capable of chaining multiple steps of reasoning to achieve complex, high-level objectives. We're talking about the difference between a user running a simple script and an agent executing a goal like a fish. Optimize the quarterly supply chain logistics based on last week's sales data.
Or something even more terrifying, like debug this entire code base and deploy the fix.
Without human review, yes.
So the transition wasn't from a sanctioned tool to an unsanctioned tool. The sources are suggesting the real shift happened when generative AI, that manual copy and pasting we all saw, was rapidly superseded by agentic AI. These are the tools that are designed to act on their own, to perform continuous operations, often without needing constant human intervention.
And that's where the risk profile just explodes. It shifts from a passive data leakage risk to one of active compounding operational errors.
And this shift is pervasive. It's not some edge case.
Not at all. The data on what the reports call quantifiable invisibility is striking. The 2025 State of Shadow AI report highlights that organizations with high shadow AI usage are absolutely typical. It's the norm now.
I have to say, the data you pulled on small businesses, it was almost unbelievable.
It's counterintuitive, isn't it? The highest risk density is in smaller organizations, those with, say, 11 to 50 employees. They average an astonishing 269 unsanctioned AI tools per 1,000 employees.
Wait, stop there. 269.
269.
So if you have a company of 20 people, you likely have 5 or 6 of these autonomous agents running around that nobody knows about.
That's it. It means nearly 27% of their workforce is relying on powerful, unknown, and critically unvetted tools just to function.
That statistical density, to me, it suggests that for smaller, more agile organizations, shadow AI isn't even disobedience anymore. It's just the default operating model because their internal IT can't possibly keep up with the pace of innovation.
It is the default. Precisely. And this exposure isn't just limited to startups. The sheer volume stays high, even in larger organizations. Those with 500 to 1,000 plus employees, they still hover around 200 shadow tools per 1,000 users.
So 1 in 5.
Still 1 in 5. This is the measurable reality of the bring your own AI phenomenon, the BYO AI trend, which has just utterly erased the traditional logical perimeter of corporate data processing.
The perimeter is gone.
It's gone. Data is moving in and out of the network through hundreds of endpoints that security teams never approved and, in most cases, have never even heard of.
And the sources connect this pervasive adoption directly to a crucial fact about financial stealth. It's not just that the security team is blind. The CFO is often completely blind to this risk.
That's where the visibility problem really begins. The fact that 29% of employees now pay for their own AI tools out of pocket isn't just some HR curiosity.
No, it's a security bypass.
It's a critical security bypass. When that subscription fee appears on a personal credit card statement, it bypasses corporate procurement. It avoids financial audits. The usage becomes completely invisible to the finance team, and therefore to the security team, that often uses those financial records to track down unsanctioned sauce sprawl.
So let's just recap. We have a workforce adopting highly autonomous complex tools, funding them personally, and operating completely outside of IT's visibility. The critical question then isn't just what they are using, but why? Why are people willing to take this massive personal and professional risk? We have to get into the psychology driving this.
Well, the impulse to adopt these tools is rarely an act of, outright malicious insubordination.
Yeah.
It's a pragmatic response to institutional friction. Employees see a readily available tool that promises to solve their biggest problem, the constant pressure to increase output.
It's that productivity force multiplier that we're all looking for. The survey data you included is the definitive incentive right there. 79.67% of users report higher output due to AI.
Almost 80%.
If you are measured on velocity, and an unsanctioned tool gives you an 80% chance of significantly improving your performance, IT policy becomes, secondary. The reward far outweighs the perceived risk.
And that risk calculation is skewed by a real lack of institutional guidance. A deeply concerning statistic shows that 50.11% of employees report receiving little to no training from their employers on how to use AI securely.
Half of them.
Just over half. This highlights a critical lack of what the sources call AI literacy at the organizational level. If the company fails to provide secure, approved tools, and it also fails to educate employees on the dangers of external tools, it's effectively pushing the workforce into the shadow economy by default.
Their hands are tied.
They are.
And that institutional neglect, it leads directly to what the sources are calling the trust paradox, which I found fascinating.
This is where it gets really insightful, the displacement of human trust. The research indicates that employees in high-stakes industries, and these are the ones where errors are most costly, like healthcare, finance, manufacturing, they now report higher levels of trust in AI tools than in their own colleagues or even their managers.
That is a staggering indictment of internal processes, isn't it? If an employee at a finance firm trusts some algorithm hosted by an unknown company more than their direct supervisor,
or their longtime colleague,
it speaks to a deep-seated functional dissatisfaction. But how does that paradox manifest as a security risk?
It creates what we call operational blindness. When you trust the AI agent implicitly, you are far less likely to question its output. You're less likely to adhere to that essential human-in-the-loop verification step.
You just accept the answer.
You accept the answer. And crucially, you are certainly not going to report potential errors or strange behavior to the very IT department you circumvented to use the tool in the first place. This just exacerbates over-reliance and makes the human operator a compromised security buffer.
So the combined result of all these individual choices is the formation of the shadow army, this secondary, invisible, autonomous workforce operating right inside the network.
And this immediately breaks traditional identity and access management, or IAM, models.
Completely breaks them.
For decades, IAM assumed one human identity equaled one actor. Now, a single human identity, once authenticated, becomes the gateway for dozens of autonomous agents. These agents are performing tasks, accessing internal databases via API keys, generating proprietary code, all under the established, approved guise of that single human's login credentials.
It's a massive expansion of privileged access without any corresponding oversight.
None.
And we know this shadow workforce is concentrated in specific high-risk departments. This isn't just about general office productivity.
No, the data reveals very clear concentrations. Marketing teams, for instance, desperate for content velocity, they use unapproved tools to draft high-volume copy. They often do this by pasting proprietary customer list or sensitive campaign data right into the prompts. That's a direct potential customer list leak.
All right, and developers.
Developers are major users. They accelerate deployment by using unapproved coding assistants to debug proprietary software, which means turning the entire source code base over to third parties.
A source code leak just waiting to happen.
It is. And then you have HR departments using AI to screen resumes or draft internal policies. They are immediately exposing highly sensitive PII, payroll data, and employee records to these external models.
Okay, so if we just look at those three departments, marketing, development, and HR, they touch three of the most highly regulated and valuable data types: customer PII, source code, and employee PII. So what does this all mean when you scale it up?
It means that each of these focused use cases represents a continuous hemorrhage of the most sensitive data. We're talking customer billing information, core proprietary source code, PII, all flowing into the training corpora of public external models. It is constant, it is subtle, and the long-term cumulative damage to a company's intellectual property sovereignty is, well, it's potentially existential.
That transition from this continuous subtle leakage to a tangible security threat is crucial. If shadow learning is the silent killer, what happens when hackers deliberately weaponize these same autonomous tools against the enterprise?
That is the pivotal shift. The sources detail a threat evolution where the risks move from these passive data leaks to active, weaponized, autonomous threats that truly redefine cyber defense. And the data shows most organizations are completely flying blind.
They have no idea.
Only 21% of security leaders have full visibility into shadow AI usage. That means 79% of CISOs are responsible for managing a massive internal workforce they can't even see.
And that ignorance, it comes with a very severe price tag.
It's my measurable one. The data clearly shows that the presence of unmanaged shadow AI is a direct leading indicator of financial loss. It's correlated with a staggering additional $670,000 cost per breach.
An extra $500,000, more than that.
That is the financial premium organizations pay for failing to govern AI. That $500,000 surcharge just destroys any perceived savings from using free tools.
Let's delve deeper into that persistent risk you mentioned, shadow learning. If it's fundamentally different from a traditional data breach, how does it cause such permanent damage?
In a traditional breach, a file is stolen. It's bad, but it's a discrete event. Shadow learning occurs when proprietary information, let's say a unique algorithm or a confidential customer list, is used often inadvertently to retrain an external third-party model.
So it's not stolen, it's absorbed.
It's absorbed. The fundamental mechanism is that the company's IP is converted into mathematical vectors and then irretrievably embedded into the neural weights of that external model.
And that's the unlearnable problem.
Precisely. Data absorbed by an LLM becomes part of its collective intelligence. You can't just send a delete command. To fully remove that data, the model would require technically complex, expensive, and often impossible retraining. It is a permanent loss of IP sovereignty.
Because your core business intelligence is now part of a third-party, publicly available knowledge base. The scale of this hemorrhaging is shocking. The Harmonic report provides a frighteningly granular breakdown of just how often this IP leakage occurs in these conversational contexts.
The finding is alarming. A shocking 8.5% of all prompts entered by employees into popular Gen AI tools contain sensitive data.
8.5%.
Think about that. If you consider the millions of prompts fired off in a large enterprise every single day, that 8.5% becomes a colossal, continuous, and systemic data leak.
Let's break down those specific data categories because the regulatory implications differ wildly.
They do. The largest category is overwhelmingly customer data at 46%.
Almost half.
Almost half. Things like billing information, PII, authentication details. Pasting this into an external tool is a direct violation of international privacy regulations like GDPR and CCPA. That's immediate regulatory risk.
The internal risk is also incredibly high.
Absolutely. 27% is employee data. Payroll records, performance reviews, sensitive employment history. Leaking this data leads directly to serious internal HR lawsuits and compliance failures related to internal data privacy policies. And then the really high-value risk is the 12% that is security and code.
The keys to the kingdom.
Literally. API keys, proprietary source code, or vulnerability reports. Developers are essentially sacrificing long-term IP security for short-term debugging speed, handing over the digital keys to the organization.
We need a canonical case study for how this systemic risk can turn into a catastrophic public incident. That brings us to the DeepSeek breach in January 2025. Can you tell us about the mechanics of that exposure?
Sure. DeepSeek, a Chinese AI provider, was really popular because of its performance and low cost, which made it a prime candidate for shadow adoption. Researchers discovered that a misconfigured database belonging to DeepSeek, it was a ClickHouse instance, was publicly accessible without any authentication whatsoever.
Wide open to the internet.
Wide open. This exposure included over 1 million lines of real-time log streams.
And within those logs was the verbatim data entered by corporate users using shadow accounts.
Correct. The logs contained verbatim chat history, which means the exact prompts containing sensitive data. It also included back-end system details and, critically, secret keys used for API access.
So any enterprise whose employees were using DeepSeek via these shadow accounts instantly had every confidential query, every pasted code snippet, and every internal business detail exposed to the public internet.
Instantly.
The strategic implications of this are immense, particularly for risk managers. Let's start with the invisible exposure.
Because DeepSeek was a shadow tool, security teams had zero visibility into which employees were using it and with what data. When the breach was announced, CISOs couldn't easily query their own network to assess exposure because the traffic just looked like generic web usage. They literally had no mechanism to perform an effective breach assessment.
And the jurisdiction matters here a lot.
A great deal. The provider's location in China added a significant layer of jurisdictional risk and geopolitical concern. This was especially relevant for defense contractors or finance firms handling highly regulated data, and it magnified the scrutiny they faced.
And then there's just the business impact.
Business continuity. Any critical workflows that had become secretly dependent on DeepSeek simply ground to a halt when the provider was forced to temporarily take the service offline due to the incident.
Okay, so that covers passive leakage and supply chain risk. Now, let's move from being a victim to facing an active orchestrated threat. This is where we see the crossing of the autonomy threshold with what the sources call the GTG 1002 campaign.
This campaign was a pivotal moment in understanding offensive AI. Threat actors used an AI agent powered by frameworks like Claude Code, not just to write a script, but to orchestrate a full cyber espionage campaign.
And this agent could self-configure. What does that mean in practice?
It means it could adapt its attack strategy based on the data it found, making it dynamic and incredibly unpredictable.
So what did the autonomous attack profile actually look like on the network?
Upon gaining initial access, which, by the way, often exploited vulnerabilities within these unvetted shadow AI tools themselves, the agent immediately began operating without human instruction. It autonomously mapped the entire attack surface, identified network vulnerabilities, generated custom exploit code on the fly to bypass specific security measures, and then moved laterally across the network to escalate its privileges.
And the machine speed of this is what overwhelms human defenders.
Absolutely. The agent executed lateral movement and credential harvesting at a rate of multiple operations per second.
Wow.
Human security analysts simply cannot process, prioritize, or respond to threats moving at that velocity.
And it was adaptive, too.
It was. Adding to the challenge, the agent maintained persistence using structured markdown files. This adaptive strategy allowed the agent to remember its previous failures and refine its attack path without needing constant communication with an external command and control server.
Which makes detection exponentially harder.
It does. It effectively turns shadow AI adoption into an internal weakness that is just ripe for co-option by these autonomous external agents.
This confirms that the risk is existential, not just operational. It's also proof that the old move fast and break things era is officially dead. The good news, I guess, if you are a compliance officer, is that the regulatory environment has finally caught up.
It has.
Shadow AI is now a direct path to litigation, and potentially crippling fines for regulated industries.
That's the core message here. Governments have signaled that corporate ignorance is no longer an acceptable defense. And let's start with the most comprehensive framework setting the global standard. The EU AI Act, which is fully enforceable as of 2025, and casts an extremely wide legal net over unauthorized AI used by deployers, the companies themselves.
I want to focus immediately on the provision that, for me, just eliminates the plausible deniability of the rogue employee.
That is Article 4, the AI literacy mandate, which is enforceable early in February 2025. The Act mandates that organizations must ensure a sufficient and demonstrable level of AI literacy among their staff.
Demonstrable being the key word.
The key word. The burden of proof is explicitly on the organization to show they provided adequate training and oversight before and during the use of any AI systems.
But couldn't an employee reasonably argue they were just using the best tool for the job, and the organization failed to provide a secure, approved alternative? Is the liability truly all on the company?
Under the EU AI Act, yes, the organization shoulders the primary liability. The failure to train is a failure of compliance. If an employee causes a breach via an unvetted shadow AI, the organization can't just fire them and claim innocence. Your failure to proactively educate and govern them is considered a failure under Article 4.
And the financial penalties associated with non-compliance are severe.
They're potentially existential. Consider Article 50, which addresses transparency and deepfakes. It mandates that users must be informed they are speaking to a machine, and any synthetic content must be watermarked. Shadow tools almost never comply with these rigorous standards.
Of course not.
So an employee using an unapproved AI to generate, say, a customer support response or an internal policy draft violates this, exposing the company to fines of up to 35 million or 7% of global turnover, whichever is higher.
7% of global turnover? That's a crippling financial exposure.
It can be a company-ending fine.
And there's also this significant sleeper issue of the general purpose AI or GPAI obligations that affects developers inside the enterprise.
Yes, if we connect this to the growing trend of using open source models, the GPAI obligations, fully active by August 2025, are a massive hidden risk. If an enterprise developer downloads and fine-tunes an open source model like Llama 3 or Mistral without rigorous IT oversight,
Which is happening all the time.
all the time, the enterprise may legally become designated a provider of a GPAI system. That status triggers massive, stringent documentation, risk assessment, and compliance requirements that the shadow team running the model is entirely unprepared for.
So a seemingly innocent developer shortcut turns into a huge legal risk for the entire company. Moving to the U.S., we see similar stringent constraints in the healthcare sector with the IPA security rule modernization. The intersection of shadow AI and protected health information, PHI, is just a recipe for catastrophic fines.
It's lethal. It's lethal because of the business associate agreement gap, the BAA gap. IPA mandates that any third-party processing PHI must sign a BAA, contractually guaranteeing stringent security and compliance standards.
And these tools won't do that.
Consumer AI tools, especially free versions of public models, do not and will not sign BAAs. The second a healthcare employee pastes a patient note into a shadow AI tool for summarization, a fundamental HIPAA violation has occurred, placing the organization directly in the regulator's crosshairs.
Given that the statistics show 44% of organizations with shadow AI incidents report compromised data, this BAA gap is less a theoretical risk and more of a systemic failure point.
It is. The new proposed HHS rules are designed to eliminate the historical ambiguity in the security rule, making strict access controls mandatory rather than merely addressable. This leaves zero wiggle room for unmanaged AI tools processing sensitive data. The cost of just a few HIPAA violations, often in the tens of millions, completely obliterates any perceived productivity benefit.
And finally, on this legal front, the legal profession itself has already established clear liability precedents for unverified AI use. And this affects every professional, from lawyers to engineers. It sets a universal standard of care.
We have concrete case law establishing this. The Amir Mustafavi case in California is the clearest example of the legal standard catching up to the technology. Attorney Mustafavi was fined $10,000, a significant sanction, after relying on ChatGPT to draft a brief that fabricated or hallucinated 21 of the 23 legal cases it cited.
And his defense was basically, I didn't know.
And the court rejected his defense of ignorance or technological unawareness completely.
So the legal standard is essentially that the human user is always liable for the machine's errors.
Precisely. This case, alongside others like Mata via Bianca, establishes a clear and non-negotiable legal standard. Human-in-the-loop verification is not optional. Reliance on unverified AI output is now deemed professional malpractice.
And that principle extends far beyond the legal sector.
It does. If an engineer uses a shadow AI agent to generate critical infrastructure code, or a financial analyst uses one to model a quarterly forecast, and that output results in harm due to a hallucination, the organization faces similar liability for professional negligence.
That's a dramatic shift in thinking. We're moving from managing data loss to managing professional liability. So if the law says we're liable for what the machine says, how on earth do we find the machines that are operating invisibly in our networks?
Well, since we agree that just banning shadow AI drives the problem deeper underground, the only viable first step for compliance is detection. The challenge is, how do you hunt an autonomous agent that operates at machine speed and is intentionally designed to mimic or operate alongside human workflows?
Right? Traditional methods focused on blocking IP addresses, they fail because these agents are often hosted on approved cloud services or use widely accepted APIs.
Exactly. Detection requires a behavioral signature analysis, distinguishing between a legitimate human accessing a service and an unauthorized AI agent executing a high-frequency, goal-oriented workflow. We have to look for the distinct digital fingerprints that machines leave behind, which humans simply cannot replicate.
Let's break down those signatures using the forensic data you provided. The first distinction seems to be in network cadence and frequency.
Humans are inherently bursty. When we use a chatbot, we pause to read the response, digest it, type a follow-up, get distracted.
Go get coffee.
Exactly. Agents, in contrast, exhibit a continuous rapid-fire interaction pattern. Their request cadence is uniform and machine speed, far exceeding human words per minute.
And their operational schedule is a dead giveaway too.
Right. Humans align with standard work schedules, even if they work globally. Agents can persist 24/7 with a statistically uniform pattern of activity. But perhaps the most telling signal of an agent is the traffic topology. A human connection is simple. Point to point, user connects to LLM server.
But agents are different.
Agents often use a star or cluster topology, where a central orchestrating agent triggers simultaneous outbound calls to multiple APIs, a knowledge base, an internal SQL database, an external weather API before reporting back to the LLM.
I think the most definitive, the most undeniable signature for Agentic AI, the one that makes the security team stand up and pay attention, is what the sources call the recursive loop.
This is truly the smoking gun for an autonomous agent. Modern autonomous frameworks like AutoGen and LangChain rely on a continuous perception reasoning acting loop, or the REACT pattern. If you monitor network logs, you will see a specific, unmistakable triangular traffic pattern.
Okay, break that down for us.
Step 1, an LLM API call. Step 2, an immediate outbound call to a tool, say, an internal SQL database or a company GitHub repository. Step 3, an almost instant callback to the LLM to process the result of that tool action.
So if I see an IP address running this pattern LLM to tool, back to LLM at sub-second intervals, that's not a human reading an email and then checking a database. That is a machine having a conversation with itself and then acting on the results.
Exactly. That triangular traffic pattern occurring at high frequency is indisputable evidence of an unauthorized agent deployment.
And we can also use framework fingerprinting.
Yes, the convenience of open source frameworks for shadow users is a huge advantage for detection teams.
So how does that fingerprinting work?
Shadow users often deploy default configurations that inadvertently reveal the agent's identity. For LangChain signatures, for example, we look for a default user agent string identifying the library, something like LangChain abo.1.0. While a sophisticated state actor might spoof this, the average shadow enterprise user does not. We can also hunt for specific tracing headers, like xtraceaid, that these frameworks inject into HTTP requests for observability by design.
And what about the frameworks designed for machine-to-machine collaboration, like AutoGen?
AutoGen signatures are characterized by highly complex WebSocket interactions. Since AutoGen's architecture involves multiple specialized agents conversing internally to complete a single task, network forensics can reveal a group chat pattern.
A group chat of machines.
A group chat of machines. It looks like a single corporate IP address managing multiple concurrent, interrelated conversation streams that are statistically unique from standard browser traffic. It's evidence of machine-to-machine activity disguised under a single human identity.
To successfully fight threats moving at multiple operations per second, security cannot rely on human analysts reacting to alerts. The sources propose that we must adopt the Agentic SOC, platform fighting machine with machine.
If the threat is autonomous, the defense must be autonomous. Defensive AI agents can be deployed to analyze security alerts autonomously, performing what we call autonomous triage. They are trained to immediately distinguish a benign, large file transfer from a malicious shadow AI data leak by querying user context, historical behavior, and checking for those react patterns, all without needing human intervention.
It reduces the alert fatigue that SOCs are drowning in.
Massively.
Yeah.
And this sounds like a new paradigm in security operations where the system is constantly self-analyzing and self-defending.
It has to be.
It has to be. Advanced defensive agents use recursive reasoning in defense. They form immediate hypotheses, for example. Is this user X or an agent acting as user X? And then autonomously collect forensic evidence to confirm or deny that hypothesis. And crucially, this enables automated containment. Upon verifying a shadow AI agent is malicious, the defensive agent executes immediate real-time actions like isolating the device or revoking the compromised API keys, halting data exfiltration before a human analyst has even clocked the initial alert.
The sources make a really compelling argument that this shadow AI crisis is, at its heart, a massive decentralized market signal. The workforce demands these autonomous capabilities, and IT isn't delivering.
That's the signal.
So the winning strategy, therefore, is not prohibition, which we know fails, but safe enablement. To sell that solution to the CFO, however, we have to destroy the myth that free AI is cheap. Let's look at the economics.
We have to. We must challenge the perception that free or build your own shadow AI is cheaper than enterprise-grade commercial SaaS. A rigorous total cost of ownership analysis, a TCO analysis, proves that shadow AI is almost always a false economy rooted in inadequate accounting of risk, labor, and infrastructure costs.
Let's break down the core buy versus build dilemma using the TCO analysis provided specifically for general-purpose AI deployment.
Okay, on the buy side, with commercial SaaS like a compliant enterprise instance, the cost structure is low capital expenditure and predictable operational expenditure. It often settles around $25 to $30 per user per month.
That's manageable.
It's manageable. And the significant value proposition is zero infrastructure management, immediate access to compliant, state-of-the-art models, and crucially, built-in legal protection via data isolation guarantees and compliance features like SOC2 certification.
Conversely, the build side deploying an open-source model like Llama 3 on private infrastructure looks deceptively cheaper up front.
It's so deceptively expensive. The build approach requires heavy CapEx for high-performance GPUs, like NVIDIA H100 clusters. It requires massive ongoing electricity and cooling OpEx, and a continuous need for specialized, highly compensated engineering talent to manage, maintain, and update the model.
So where is the economic break-even point? At what scale does building your own actually become cheaper than buying a subscription?
The research provides a very clear framework. On-premise deployment only becomes economically viable for organizations with extremely high-volume processing requirements.
And how high is high?
Specifically 50 million tokens per month or more, or those with absolutely rigid regulatory data residency mandates. For the vast majority, easily 90% of enterprises building and maintaining a general-purpose AI solution is economically irrational.
It just doesn't make sense.
It doesn't. The talent, infrastructure, and hidden management costs far exceed the subscription fees. The strategic conclusion is that the most cost-effective solution for control is often simply procuring the enterprise-grade SaaS that employees are clearly demonstrating they want.
And that cost analysis doesn't even factor in the hidden punitive costs of free usage.
Exactly. Those hidden costs destroy any perceived savings instantly. First, the breach premium. That average breach cost premium of $670,000 for incidents involving shadow AI. Second, technical debt. Shadow AI generates phantom code software written without documentation, security vetting, or clear ownership, which exponentially increases the long-term cost of software maintenance.
And finally, the legal fees.
The legal fees. Regulatory investigations, the crippling fines under the EU AI Act, and litigation for professional malpractice, as we saw in the Mustafabi case, they quickly dwarf any license savings. Shadow AI is expensive, legally dangerous, and technically unsustainable.
The conclusion for leadership seems clear. This is not a technology problem, it's a governance architecture problem. How must governance pivot from generic IT policies to the AI-specific models necessary for resilience?
Governance has to pivot entirely to safe enablement, guided by liability avoidance. And the foundation for that is the acceptable use policy, the AUP, which must be granular and AI-specific for 2025. It cannot be a tacked-on addendum to an old IT policy.
So what are the three most critical AUP clauses that CISOs and compliance officers need to implement immediately?
First, scope and definition. You must explicitly define terms like AI agents, generative AI, and autonomous systems, so there is absolutely zero ambiguity about what is covered. Second, the data classification matrix is essential. It must clearly detail where public data can be used, where internal data can be used, and where restricted data, like PII, PHI, source code, is strictly prohibited, often only allowed in air-gapped internal sandboxes.
And the clause that protects against that most of you type liability, the one that keeps you out of court.
That is the ultimate defense. The human-in-the-loop mandate, the HITL mandate. That AUP must explicitly state, perhaps in bold, that any AI output impacting business decisions, financial transactions, code production, or external communication must be reviewed and verified by a qualified human. This clause is the organization's primary defense against professional malpractice liability.
And finally, that AI literacy imperative we discussed under the EU AI Act. Governance is entirely theoretical without the training to back it up.
It is unenforceable. Organizations have to implement a tiered education strategy to comply with the EU AI Act's Article 4.
Break down those tiers.
We need Tier 1 training for the general workforce, focusing on the AUP, basic data privacy, and the risks of hallucination. Tier 2 is for technical staff developers, data scientists focusing on secure AI development, prompt injection defense, and the practice of avoiding hard-coding secrets and agents. And finally, Tier 3 for leadership, focusing on strategic risk management, regulatory compliance like GDPR and HIPAA, and the ethical and legal implications of enterprise deployment. This tiered approach ensures that knowledge, and thus accountability, is correctly distributed.
Okay, let's synthesize what we've learned. The shadow AI crisis of 2025 is fundamentally a crisis of visibility and governance. It's fueled by a genuine, undeniable employee demand for these autonomous capabilities.
It really is.
We saw that the shift to agentic AI brings not just passive data leakage or shadow learning, but active autonomous threats like the GTG 1002 campaign, which operate at speeds human security teams just cannot match.
Exactly. I think the biggest takeaway for you, the learner, is that ignorance of this threat is now effectively criminalized under these new regulatory frameworks. The liability for unverified autonomous output is fully established in the courts. The winning way forward is not to ban, but to safely absorb the shadow army, to transform a weakness into an asset.
Before we wrap up, for the CISO or the compliance officer listening right now, based on our forensic review, what are the three immediate actionable steps they should execute this week?
Okay, first, deploy network forensics focused on behavioral signatures. You have to use agentic SOC methods to hunt for that React pattern immediately. You cannot manage what you cannot see. Second, conduct an immediate financial audit of expense reports to trace personal AI subscription payments and identify the hotspots of shadow usage. And third, update your AUP with a clear, non-negotiable human-in-the-loop mandate to establish your defense against professional malpractice liability.
The organizations that thrive will be those that view this decentralized market signal as an urgent mandate for managed, secure, and incredibly productive digital transformation, governed by clear, enforceable AI literacy standards.
This raises an important question for you to consider based on the legal precedents we reviewed. If the legal standard is now established that a human is always liable for an AI agent's hallucinations, and the cost of the breach is an extra $670,000, how long before corporate insurance policies refuse to cover damages or legal fees resulting from decisions made by an unvetted shadow AI agent, regardless of internal policy?
And they will.
That's something to mull over as you restructure your governance models and renegotiate your corporate liability policies.
Fascinating stuff. That's all for this deep dive. We look forward to unpacking your next stack of sources soon.